Example 8.8. Consider a positive integer 28 and now denote it as n. Now consider the divisors of 28. The positive divisors of 28 are 1, 2, 4, 7, 14 and 28. Now CD means, D means divisor. So C1 means a class. C1 denote a class with a special property, and that property is C1 is a class with integers m, and that integers m are relatively prime to 28. That is, C1 is a set of all integers m which is less than or equal to 28, and the GCD of m comma 28 is 1. Now, what are the numbers less than or equal to 28 and with GCD equal to 1? That is, and we know 1 and 28 are relatively prime. That is, the greatest common factor of 1 and 28 is 1. So 1 belongs to C1. Then now consider 3. The GCD of 3 and 28 is 1. So 3 element of C1. Now 5. GCD of 5 and 28 is 1. So 5 element of C1. Similarly, all these elements are in C1. Then what is C2? This is C2. C2 means set of all integers m less than or equal to 28 with not only that, the GCD of m and 28 is equal to 2. Now consider 2. The GCD of 2 and 28 is 2. GCD of 6 and 28 is 2. GCD of 10 and 28 is 2. So all the numbers which are less than or equal to 28 and with GCD, and if we consider GCD with 28, it should be 2. Those numbers should lie in this class C2. And this is C4. Then what is C4? C4 is the set of all integers m which is less than or equal to 28, and the GCD of m and 28 is 4. Example, this one 4. GCD of 4 and 28 is 4. GCD of 8 and 28 is 4. And GCD of 20 and 28 is 4. So all these numbers belongs to C4. Now consider C7. As usual, C7 the set of all collections, set of all integers which is less than or equal to 28, and the GCD of m and 28 is 7. So 7 and 21 are examples. And 14, C14 is set of all integers less than or equal to 28, and GCD of m comma 28 is equal to 14. Only one possibility, 14. GCD of 14 and 28 is 14. Then C28 is set of all integers m less than or equal to 28, and the GCD of m and 28 is equal to 28. That is, I first consider a positive integer n, then I consider all the positive divisors of n, that is n equal to 28, or the positive divisors of 28, and corresponding to each divisor I define a class, say C1, C2, C4, C7, C14 and C28, and these are the elements of those classes. These are the elements. Now I wish to evaluate the number of elements in each class. Now it is clear that there are 12 elements in C1. That is, the cardinal number of elements in C1 is 12. By counting, it is clear that this is 12. And number of elements in C2 is 6, C4 is 6, C7 is 2, C4 is 1, C14 is 1, C28 is 1. Then, what is phi of 28? Phi of 28 means number of integers less than or equal to 28 and relatively prime to 28. That is phi of 28. By computation, phi of 28 is 12. That is, in C1 there are 12 elements and that 12 is equal to phi of 28, and phi of 28 means phi of 28 by 1, and this one is the divisor 1. And in C2 there are 6 elements and 6 means phi of 14, and this 14 is 28 by 2. That is, phi of 14 is equal to phi of 28 by 2. This 2 is the divisor. And in C4 there are 6 elements. 6 is equal to phi of 7, and that phi of 7 is equal to phi of 28 by 4. What I mean is that the number of elements in C1 is phi of 28 by 1. 1. This divisor is here the denominator. In C2, phi of 28 by 2. This C4, phi of 28 by 4. This same 4. Then C7, phi of 28 by 7. 7. In C14, phi of 28 by 14. C28, phi of 28 by 28. That is, each class, if I denote this 28 as n, and the divisor as d, n is equal to 28, d is the divisor, the number of elements in class CD, number of elements in CD is equal to phi of n by d. Is it clear? That is, the number of elements in CD is equal to phi of n by d. D is the divisor. And now I am going to add all these elements. 12 plus 6 plus 6 plus 2 plus 1 plus 1. 18, 24, 26, 27, 28. This is 28. This is 28. And what is this one? This is phi of 1, phi of 2, phi of 4, phi of 7, phi of 14, phi of 28. Sum of all these numbers. Sum means sigma. Sum means sigma. Sigma of what? Sigma of phi of something. That is phi of 1, 2, 4, 7, 14, 28. And this 1, 2, 4, 7, 14 and 28 are the divisors of 28. That is sum of phi of d. D. And what is d? This d is the divisor of 28. This d is the divisor of 28. That is 28 is equal to sigma d divides 28 phi of t. And by using, and what is 28? 28 is the number n. This is our n. By this example, we get sum of, by this example, 28 is equal to sigma d divides 28 phi of d. And next, I am going to prove a theorem, and that theorem states that for any positive integer n, n is equal to sigma d divides n phi of t. This is theorem 8.5. This is theorem 8.5. To prove this theorem, we should follow the same procedure which I discussed in this example. Let us start. First, we consider the positive integer n. To prove this theorem, first we consider the positive integer n. And I list all the numbers from 1 to n, 1, 2, 3, etc. n. Then now I am going to put all these numbers in some classes, say CD, as follows. Then what is CD? CD is the collection of all numbers which is less than or is equal to n. That is, from this example, CD, that is C1. C1 is the collection of all numbers. These are the elements in CD, and all these numbers are less than 28, less than or is equal to 28. So what is CD? CD means the collection of all numbers which are less than or is equal to n, and the GCD of n and the GCD of, that is Cn, is the collection of all numbers m such that the GCD of m and n is equal to d, that is CD. So clear, CD is the collection of integers m less than or is equal to n, and the GCD of m and n is equal to d. These are CD. And now my aim is to evaluate the number of elements in CD. For that, first consider n by d. N by d. What is n by d? For example, here in this example, I wish to evaluate the number of elements in C4. Then C2. For that, I consider 28 by 2. 28 by 2. 28 by 2 is 14. And the numbers which is, okay, first consider 28 by 2, that is 14. And what is phi of 14? Phi of 14 means the number of integers less than or equal to 14 and relatively prime to 14. And that numbers are, and the numbers which are relatively prime to 14 is 6. That is, if I want to evaluate the number of elements in C2, I first consider n by 2, then find phi of n by 2. That is, first I consider n by 2, then find phi of n by 2, and here 2 is d. That is, to find the number of elements in CD, first consider n by d, then find phi of n by d. This n, we can find a class. This is clear from the example that corresponding to the divisor 2, there exists a class C2. Just like that, corresponding to every divisors of n, there exists a class CD. And the class CD is disjoint. What I mean is that if we consider the element 18, this 18 exactly lies only this class C2. And if I consider an element 21, this 21 lies exactly on this class C7. That is M. What is M? M is the numbers less than or equal to n. All m's, that is all the numbers less than or equal to 20, less than or equal to n, exactly lies only one class CD. And If I add all this number, by the example we get, this is our 28 total number. And similarly, if I add all these numbers, that is, if we sum all the cardinality of C by D, sorry, all the cardinality of CD, we will get the total number n. That is, if I sum all the cardinalities, cardinality means total number of elements in a set, all the cardinalities of CD, and we know the cardinality of CD is phi of n by d. Sum means sigma. And what is D? D is the divisor of n, is equal to n. And what is this n by d? Consider here, look at here. Here n is 28, d is 2. So n by d is 14. 14 is a divisor of 28. Then here n by d, d is 1. N by d is 28. 28 is also a divisor. Then here n by d, d is 7. N by d is 4. 28 by 7 is 4. And 4 is also a divisor. That is, this n by d is nothing but it is a divisor of the given number n. So I can replace this n by d by, this can be written as sigma d divides n, the phi n by d is equal to d, that is equal to n. That is, sigma d divides n, phi of t is equal to n. This is theorem 8.5. For any positive integer n, sigma d divides n, phi of t is equal to n.